Good morning students. Now we are studying new chapter of chemistry, atoms and molecules. The atoms was actually it was discovered by the first Indian philosopher Maharishi Kalan. Maharishi Kalan, according to him, Maharishi Kalan, he was an Indian philosopher, and according to him, if we divide any matter into the smaller particle and we are going to subdivide it such that we got the smallest particle of that matter. So the smallest particle which cannot be further divided, if we divide something like this is chalk, I am going to divide this chalk into the smaller particles. Then the smallest particle which we will get after dividing it, which cannot be further divided, is called atoms. So Maharishi Kalan said that the smallest particle by which every matter, either solid, liquid or gases, are made up of is called Parmanu. Because he was a Indian scientist or Indian philosopher. So in Hindi we call atoms as Parmanu. So he said the name of the smallest particle of which the matter is made up of is called Parmanu. Later, another scientist called John Dalton. According to him, he said that according to him, every metal in this universe, either solid, liquid or gases, are made up of the smallest particle is called atom. So the name atom was given by the scientist called Dalton. So Dalton gave the name atom to the particles which cannot be further divided. He said that this is the smallest particle and we can't divide this particle, that is called atom. So the first atom was discovered by Maharishi Kalan and then was further discovered by John Dalton. Another Indian scientist, Indian philosopher, the name was Katyayana. According to him, these atoms, Parmanu, cannot be exist in a free form. They always exist in a combined form. Not always. Most of the metals exist in a singular like atoms form, but most of the elements do not found in a free state. They always combine with another element or the same elements to form molecules called molecules, or in Hindi we said it anu. So he said that these atoms cannot exist freely. It cannot exist freely. It always combines to form molecules. So molecules was discovered by the scientist Katyayana. So now in this chapter we will study the laws of chemical combination. We have 3 laws of chemical combination, out of which we have to study 2 laws. So now we are going to study laws of chemical combination. Laws of chemical combination. The first law is law of conservation of mass. Law of conservation of mass. So just try to understand what is this law. This law was given by the scientist called Lavoisier. Lavoisier. Okay. So Lavoisier was the first scientist who gave the law of conservation of mass. So according to this law, every matter in the universe neither be created nor be destroyed. It means it remains conserved. So according to the law of conservation which was given by the scientist Lavoisier in 1774, yes, he said that the matter neither be created nor be destroyed. One form of matter can be converted into another form, but we can't destroy it or we we can't create the another new metals. So this law means matter can neither be created nor be destroyed, and this is called the conservation of mass. We can also derive this conservation of mass by an experiment which we can't do at home. Suppose we have calcium carbonate having the mass of 100 gram. Now we are going to heat it. This is calcium carbonate made up of 3 kinds of particles. It is called atom: calcium, carbon and oxygen. It forms a compound that is called calcium carbonate. Calcium carbonate is found in marble, it's found in eggshell. Eggshell is made up of calcium carbonate. Even this chalk is made up of calcium carbonate. So this is calcium carbonate, and if we take the 100 gram of calcium carbonate and just heat it. If we heat this calcium carbonate, it divides into 2 forms. This is calcium oxide and carbon dioxide. While we are going to do this experiment, we have to take a precautions that this carbon dioxide should not be evolved from the experiment. So after the heating of this substance, we found that the mass of this calcium oxide is 56 gram. And this carbon dioxide having a mass of 44 gram. So it means the total mass of the reactant should be equal to the total mass of the product. You should ensure that the carbon dioxide should not be evolved, it should not be going to the atmosphere. So the total mass of reactant is equal to the total mass of product. So it's why we can say that matter cannot be created, it cannot be destroyed, even though it can convert from one form to another form. Okay, one more experiment from your book, NCERT book. In a conical flask, we take a liquid called sulfuric acid. Let me check, either we have to take sulfuric acid. Okay, sodium sulfate and barium chloride. So we have a liquid here, it is sodium sulfate. In this chapter, we will study about how we can write down the formulas of these compounds. Like sodium is represented by the symbol Na, which having the valency +1, and sulfate having the symbol SO4. Sulfate is SO4 and has a valency of -2. So I will explain you later that how you write the formulas of these compounds. Like this is 2 and this is 1. And we crisscross the valencies of these compounds. Like 2 will be right here and 2, and 1 will be right here in SO4 pole 1. So we don't need to write 1. So the formula for the sodium sulfate is Na2SO4. Now we take the sodium sulfate in this conical flask, and in a test tube we take barium chloride. Okay, I will try to explain the formula side by side with the reactions. Like suppose barium chloride, then how will you know that what is the formula for barium chloride? So barium having the valency +2 and chloride having the valency -1. So the formula will be BaCl2. This is a barium chloride. So first we set up such type of apparatus in which we take a sodium sulfate in the conical flask and take barium chloride in a test tube and just weigh this apparatus. You will weigh this apparatus. Now what will you do? You will drop the thread here so that this test tube drop into this liquid and this barium chloride mix with the sodium sulfate. Now what will happen if barium chloride will mix with sodium sulfate? This is barium chloride and this is sodium sulfate. So in most of the reactions, this is called the double displacement reactions. Most of the reactions, this element combined with this one and this element combined with this one. This is called the double displacement reaction. So now barium sulfate. We are doing this experiment because we know that barium sulfate form the PPT, which is white in color, so that we can ensure that the chemical reactions is actually happening. So it forms the barium sulfate plus NaCl. So this barium sulfate has white PPT. So actually what happened, when we drop this test tube into this solution, the reactions takes place like this. And after the reaction, we get the white PPT here. White PPT, okay, we don't know about the PPT. PPT is the precipitate. And precipitate is just like the curd we formed at home. So PPT is just like a curd. And PPT is formed when something is insoluble in the liquid. It means this barium sulfate is not dissolved in this solution, so that we get the white PPT of barium sulfate. Now after this reaction, it shows that the reaction occurs. This white PPT shows that the reactions actually occur. After the reaction, we get the white PPT here, and then again we will weigh this apparatus. We will find that the weight of the apparatus before the reaction is equal to the weight of the apparatus after the reaction. It means this matter cannot be created, cannot be destroyed. It means the total weight of the substance before the reaction is equal to the total weight of the product. Total weight of reactant is equal to the weight of product. This is called the conservation of mass. So this is the experiment of NCERT book. And again we have some numerical question of this related to this conservation of mass. Suppose the question is sodium carbonate react with ethanoic acid. So in question we have sodium carbonate. Sodium carbonate. The formula of the sodium carbonate. Sodium is Na having the valency +1. Carbonate is a CO3 having the valency -2. The formula will be Na2CO3. We have to learn this formula in this chapter, hydrogen molecules. So sodium carbonate, according to question, sodium carbonate react with ethanoic acid. It react with ethanoic acid. Ethanoic acid. Now you don't need to learn the formula of ethanoic acid. It is CH3COH, but you don't need to learn it. Ethanoic acid to form, it will form sodium ethanoate. So I have to make a space here. These are the reactants, sodium carbonate and ethanoic acid. And the product is sodium ethanoate. Sodium ethanoate. I am going to write in the formula of this compound, but you don't need to remember this formula. It is CH3COONO. Sodium ethanoate and carbon dioxide and water, plus carbon dioxide, CO2 and water. So these are the products. Carbon dioxide and water. In the experiment, 5.3 gram of sodium carbonate. So what we are taking? We are taking 5.3 gram of sodium carbonate. The mass of the reactant, that is sodium carbonate, is 5.3 gram. And the reactant 6 gram of ethanoic acid. And what is the mass of the ethanoic acid? It is 6 gram. It forms 8.2 gram of sodium ethanoate. The mass of sodium ethanoate is 8.2 gram. And 2.2 gram of carbon dioxide. 2.2 gram of carbon dioxide. And 0.9 gram of water. 0.9 gram of water. So we have two reactants, and after the reaction, three compounds are formed, and we have the mass of the reactant as well as of the product. Now the question is, show that the data verifies the law for conservation of mass. You have to verify this, that this data show it verified the law of conservation of mass. So you will say that the total mass of reactant, total mass of reactant, it is equal to the mass of sodium carbonate as well as the mass of ethanoic acid. It is 5.3 gram Now the total mass of product. Since we know that according to the law of conservation of mass, the total mass of the reactant should be equal to the total mass of product. In case the matter cannot be created nor be destroyed. So total mass of product is sodium ethylate, it is 8.2 plus carbon dioxide 2.2 plus water is 0.9. Now let's add these terms. 9 and 2, 11 and 2, 13. 3, 1 carry, 8, 1, 9, 10, 11, 11. It is 11.3 gram. It means the total mass of the reactant is equal to the total mass of product. It verifies the law of conservation of mass. That is, matter cannot be created nor be destroyed. Okay, I am taking one more example of conservation of mass, the particle based on conservation of mass. So we are talking about the first law of conservation, chemical combination. This is law of conservation of mass. It was given by the scientist Lavoisier, and according to this law, matter cannot be created nor be destroyed. It can be converted from one form to another form. Okay. So one more question is, calcium carbonate decomposes on heating. Okay, let's talk about the formula of the calcium carbonate. Calcium carbonate. Okay, once let me check, is my phone working or not? Yeah, it's working. So calcium carbonate, what should be the formula of calcium carbonate? Calcium having valency 2 plus 2, carbonate having valency minus 2. So the formula is CaCO3. This is calcium carbonate. On heating, when we heat this calcium carbonate, it decomposes to form calcium oxide, CaO plus CO2. It decomposes to form calcium oxide. Okay, let me tell you about the formula of the calcium oxide. Calcium oxide. Calcium having valency plus 2, oxide having valency minus 2. So the formula will be CaO and carbon dioxide CO2. So after decomposition of calcium carbonate, we get calcium oxide and carbon dioxide. On heating to form calcium oxide and carbon dioxide, when 10 gram of calcium carbonate, we have the mass of this calcium carbonate which is 10 gram. 10 gram of calcium carbonate decomposes completely, and then 5.6 gram of calcium oxide. 5.6 gram of calcium oxide is formed. The mass of calcium oxide is 5.6 gram. Calculate the mass of carbon dioxide formed. You have to calculate the mass of the carbon dioxide. You will say that according to the law of conservation of mass, we know that the total mass of reactant is equal to the total mass of product. So the total mass of reactant is equal to the total mass of product. So the mass of reactant is 10 gram is equal to the mass of product is 5.6 gram is the mass of calcium oxide, and let the mass of carbon dioxide is X. Then you will say 10 is equal to 5.6 plus X. Now you can find out this value of X is equal to 10 minus 5.6. It will be 4.4 gram. So this is the mass of carbon dioxide formed when we heat the calcium carbonate. It follows the law of conservation of mass, which was given by the scientist Lavoisier. Okay. So this was the first law. Now let's talk about the second law of conservation of chemical combination. This is the law of constant proportion. So this law was given by the scientist called Proust. Law of constant proportion. Law of positive proportion. It was given by the scientist Proust in 1779. Proust was the scientist. He gave this law, law of constant proportion. According to this law, elements combine together in a fixed proportion by mass to form a compound. Actually, the law was a chemical compound always consists of the same element combined together to form a compound. Combined together in a same proportion by mass also. Again, I am telling the law. In a chemical compound always consists of same element combined together in a same proportion by mass. Yes. The meaning of this law is, suppose we are taking the example of water. We know that water is made up of two elements, that is hydrogen and oxygen. Hydrogen combined with oxygen to form water molecule. So according to this law of constant proportion, the water molecule always consists of two elements, the same elements, hydrogen and oxygen. It can't be happen that other than these elements, the element can be there like carbon, sulfur. So always a chemical compound consists of the same element combined together. Now, in a same proportion by mass, what is the meaning of this sentence? You have to learn the molecular mass or atomic mass of every element, because in this chapter you should know the atomic mass of the elements. You should know their valencies. So you have to learn the mass of the elements. So okay, I will talk about the mass of some elements in later. Sorry. I will tell you the mass of some elements later. Now, hydrogen and oxygen combined to form the water molecule. The atomic mass of hydrogen is 1. So here is 2 atoms of hydrogen. So we can see the mass of hydrogen. Suppose we are taking the ratio of hydrogen and oxygen. And hydrogen having the mass of 1 into 2. Mass of hydrogen is 1 and we have 2 atoms of hydrogen. So we will write the mass as 2. Ratio. What is the atomic mass of oxygen? It having the atomic mass of 16. So we will get 2 ratio 16. Or if you are going to simplify this one, we will get 1 ratio 8. So if you form the water molecule by any method, the water molecule will always contain hydrogen and oxygen combined together, and this will combine in the same proportion of mass, same proportion by mass. This is the law of constant proportion. A chemical compound always consists of the same elements chemically combined together in a same proportion by mass. Taking one more example, like carbon dioxide. So we can make the carbon dioxide with many methods, like we can make carbon dioxide by heating the carbon, C plus O2 gives CO2. Even though we just study that when we heat the calcium carbonate, it will form calcium oxide plus carbon dioxide. So it means we can form carbon dioxide with very different methods. Now, according to this law, carbon dioxide will always contain carbon and oxygen ions. That's true. Carbon dioxide always contains carbon and oxygen. And the ratio of the carbon and oxygen is fixed. Like the mass of carbon is 12 and the mass of oxygen is 16. So let's divide it, let's simplify it. We will get 4 ratio, 3 ratio. 4 3s are 12 and 4 is 16. So it means carbon dioxide, this is a chemical compound, carbon dioxide. It having a fixed element combined together, that is carbon and oxygen. They combine together in a fixed proportion by mass, that is 3:4. CO2, oh, really sorry for that. CO2. O2 is here, it is 16 into 2. It should be 32. Yes. 12 ratio 32. So be very careful. Yes. So 12 ratio 32. It means if we divide it by using by 4, 3 ratio 4 into 32. So the carbon and oxygen will always combine in a fixed ratio, that is 3 ratio 8. They will commonly combine in a fixed ratio, that is 3 ratio 8. Suppose the mass of the carbon, for example, the mass of the carbon is 3 gram. Then the mass of the oxygen will be 8 gram. So this is called the law of chemical combination. Constant proportion. This is the second law of constant proportion. A chemical compound always consists of same element combined together in a fixed proportion by mass. So this is the second law, and also we have some numerical question of this based on this law. So this law was given by Proust in 1779. And according to this law, always chemical compounds combined together. Always chemical compound consist of same elements combined together in a fixed proportion balance. So let's take one example. In an experiment, we have 1.288 gram of copper oxide. The mass of copper oxide. The mass of copper oxide is 1.288 gram. Okay, this is the mass of copper oxide. Was obtained from 1.03 gram of copper. The mass of copper in this compound is 1.03 gram. This is the mass of copper which combined with oxygen to form copper oxide having the mass of 1.288 gram. In another experiment, this is one experiment in which we obtain copper oxide by heating copper having the mass of 1.03 gram and we obtain 1.288 gram of copper oxide. In another experiment, we found that 3.672 gram of copper oxide. So in another experiment, we got the mass of the copper oxide. I have to. So what is the mass? 3.672. 3.672 gram is the mass of copper oxide in another experiment, in which we take 2.938 gram of copper. 2.938 gram of copper. We have this is a mass of. You will get the mass of copper oxide, mass of copper. Here also the mass of copper oxide and the mass of copper. Show that this figure verifies the law of constant proportion. You have to show that this experiment shows the law of constant proportion. According to the law, we know that in copper oxide, copper and oxygen will always combine in a fixed ratio to form the copper oxide. So now we have to verify that the copper will combine with a fixed amount of oxygen to form this copper oxide. So we have the mass of copper oxide, we have the mass of copper, so we can also find the mass of oxygen which combine with this copper to form this copper oxide by subtracting it. Minus 1.03. Okay, we have to subtract 8 minus 3, 5, 2 and 0.0. This is the mass of oxygen. Okay, we can also find the mass of oxygen in another experiment. So the mass of oxygen is equal to 3.672 minus 2.938. And we will get 12 minus 8 will be 4 and 6 minus 3, 3 and 16 minus 9, 7, 0. So this is the mass of oxygen in another experiment. Now according to the law of constant proportion, we know that the ratio of copper and oxygen should be equal. So we are going to find the ratio of copper and oxygen in the first experiment. This is 1.03 is the mass of copper and 0.258 is the mass of oxygen. So let's divide both the terms by 0.58 because we will get here 1. If we divide both the terms by 0.258, what are we doing? We are choosing the smaller term out of these two. So we get this smaller term and we divide both terms by this smaller term. So 1.03 divided by 0.258. So what should be the quantity? I think it will be like 4 iron. Yes. Near about, not exactly. It is 4. Exactly. It is 3.99. So we will divide both the terms by the single term, that is 2.58. Here 2.58 हमने क्या करा, जो भी नंबर छोटा था उससे दोनों को डिवाइड कर दिया. So we get 3.99 ratio 1, or we can say approximately 4 ratio 1. So in this experiment we found that the copper and oxygen combined with the ratio 4 ratio 1. Now let's talk about another experiment. So what is the ratio of copper and oxygen in this experiment? Copper is 2.938 ratio 0.734. Again, I told you that the number which is smaller, we will divide both the term by the smaller number. So 2.938 upon 0.734 ratio 0.734 upon 0.734. So here we will get here about 4, or the exact rate will be, yeah, it will be here about 4. So 4 ratio 1. So again in this experiment we found that the ratio of the copper and oxygen is again 4 ratio 1. So it showed that in copper oxide the copper and oxygen will always combine in a fixed ratio in fixed proportion by mass to form the copper oxide. So this numerical show the verification of law of constant proportion. Okay, I am going to discuss only one more question. This is from NCERT book. You have to write this experiment, these questions in your notebook, this numerical question in your notebook. The question is hydrogen and oxygen are combined with the 1 ratio 8. We know that hydrogen and oxygen always combine with the ratio 1 ratio 8. By mass to form the water. What is the mass of oxygen gas would be required to create the completely 3 gram hydrogen gas? Now we have the mass of hydrogen which is 3 gram. I think you know about the unitary method. You learned unitary method in class 6th, class 5th, 6th, 7th. In those classes you learned about the unitary method. So in unitary method we know that according to this ratio we know that 1 gram of hydrogen combined with the 8 gram of oxygen. So we will write that 1 gram of hydrogen will combine with oxygen is equal to 8 gram. So 1 gram of, according to this ratio we found that the 1 gram of hydrogen will combine with 8 gram of oxygen. Now what mass we have? We have 3 gram of hydrogen. So 3 gram of hydrogen will combine with oxygen is equal to, suppose you have the value of 1 gram and you have to find the mole value more than 1. So what will you do? You will multiply 3 with this 8. So 3 into 8 is 24 gram. You can also do this question like this. Hydrogen upon oxygen is equal to 1 upon 8. Okay. Now you have the mass of hydrogen, that is 3. And you have to calculate the mass of oxygen. The method which you find easy, you can use two-step method, either this one or this one. So we can calculate it, right? They will multiply and this one will multiply. So 1 into x is equal to 3 into 8. So what is the value of x? It is 24 gram. So you can use any of the methods. You can choose any of the method, either this one or this one for calculating this question. This is a question from NCERT. Okay, one last question from NCERT. 3 gram carbon burns to form burning 8 gram of oxygen. It is given that 3 gram carbon combined with 8 gram oxygen. Okay, this is given. To form 11 gram of carbon dioxide, you have to calculate the mass of carbon dioxide will be formed if 3 gram of carbon combined with 50 gram of oxygen. They will combine to form 11 gram of carbon dioxide. Now you have the mass of carbon which is, it was 3 gram. Okay. Again you have 3 gram of carbon, but here the mass of oxygen is 50 gram. Then you have to calculate what is the mass of carbon dioxide. If we follow the law of conservation of mass, so we will say that the total mass of reactant 50 plus 3, 53 should be equal to the total mass of product, that is carbon dioxide 53 gram. But it is not happen actually. Why? Because it also follows the law of constant proportion. According to this, we know that 3 grams of carbon will always combine with a fixed ratio of oxygen to form the carbon dioxide. Even first experiment, we found that 3 grams of carbon combined with 8 grams of oxygen. Then in the middle experiment, it will also 3 grams carbon combined with 8 grams of oxygen. It doesn't matter how much oxygen is available here. It will always combine with another element in a fixed proportion by mass. This is the law of constant proportion. So 3 grams of carbon will always combine with 8 grams of oxygen, not with the 50 grams of oxygen. Okay? So 3 grams of carbon will combine with 8 grams of oxygen and form 11 grams of carbon dioxide. So this is a very interesting question. Okay? Now we have studied about the 2 laws of chemical combination. The first was the law of conservation of mass, which was given by the scientist Lavoisier, and according to him, the mass of any matter cannot neither be created nor be destroyed. Second law was the law of constant proportion. This law was given by Proust, and according to him, in a chemical compound always consists of same element combined together in a fixed proportion by mass. So now we know the 2 laws of chemical combination. In next